This is a short item analysis for retake assessments in Module 1 and Module 2 of CSC 243, Spring 2021. Students did very well on the retakes. In Module 1, the average score was 4.21 out of a possible 5. We will, however, review the questions that pose the greatest difficulty. So we'll be taking a look at these and then one or two on the Module 2 retake. True or false, a serial connection can be full duplex with different send and receive data rates. This is true. It's called an asynchronous connection. Full duplex means send and receive is happening simultaneously, but they can be at different data rates. What does /16 mean? If you have a /16 address, you're given the following IP address for CIDR notation. What does the /16 mean? That's a problem. However, if we look at the question itself and then look at the answers, there's no answer that refers to a /8. So that's an administrative error. In any case, /16 means there are 16 ones in the subnet mask for a Class B address range. That's why it's a Class A range would have 8 zeros, a Class C would have 24 ones and 8 ones respectively. So Class A would have 8 ones. This talks about zeros and ones. So in a Class A range you'd have 24 zeros, in a Class A range you'd have 8 ones. The number of ones and zeros has to add up to 32. So you'd have, for a /16, you'd have 16 ones and 16 zeros. For a Class A, you'd have 24 zeros and 8 ones. And then for a Class C, you'd have 24 ones and 8 zeros, respectively. What interest led to the Internet? Which was funded by DARPA in 1973. It was packet switched data networks are resilient to a nuclear weapons detonation. So in the Cold War, there was concern that circuit-based networks would be too vulnerable. With a few well-placed nuclear detonations, communications could be severed for much of the country with circuit switch networks. So DARPA wanted to fund research into the development of digital packet-based networks. And that's what led to the Internet, ultimately. Which private address range? You must configure a private internal network to support 120 users for a growing mid-sized company. You must choose the right size private network. Which network range should you choose? Well, if you choose a B or an A, you're talking about 65,000 addresses or millions of addresses. That's overkill. A Class C address range is really the only one that makes sense. And it's the only answer that satisfies the criteria. You want to provide for some growth. You have 120 users. There are 253 usable IP addresses in a Class C range. What happens? What happens to the headers of packets as they travel down the OSI layer of a protocol stack for delivery on an IP network? As they're traveling down the layer, the data is being sent on that client out onto the network. So as it's traveling down, the headers are preserved and encapsulated inside a frame using a MAC. When you see the word packet, we're talking about layer 3. As you pass down the OSI layer, the next layer down from layer 3 packets are frames. And those have MAC addresses. So the headers are preserved on the packets. It's encapsulated into a frame. The other answer choices are bogus choices. The one that most students chose in error, the headers are discarded to reveal the IP address in the packet header. That's wrong on several levels. Headers are discarded as data travels up the OSI stack, and it reveals progressively smaller chunks of data. So you have frames that give way to packets that give way to datagrams. So Um, but if you're dealing with packets and you're revealing the IP address, there would be no IP address on the next higher layer. If you're on layer 3 with an IP address and you unpackage that and send it up, it would be a datagram, not a packet header. It would be a datagram header. So that first choice is wrong on more than one point. Postel. Postel, a pioneer of network protocols, related one should be conservative or strict with the data that one sends to others, though liberal or receptive with the data that one receives from others. This is correct. If that's reversed, then you have misfires with communications. You have unreliable communications. So that's what Postel related. In fact, that's pretty much the statement of his paradigm or his concept. All right, so we're going to take a look at this. Concludes our review of issues for questions on the retake. Now we're going to shift gears and go to the Module 2 retake assessment and look at the item analysis for this. There were only a couple of items. Student performance on Module 2 retake was even higher, 4.6 out of a possible 5. We only had a couple of questions that were a challenge, multiple choice. Select the answer below that accurately reflects how copper wire in an Ethernet cable works so well, even when subjected to electromagnetic fields from nearby electrical power sources. In slides from the author and in your textbook and in other online references in the study guide, it basically shows that there's electromagnetic interference, and if you have untwisted wire, basically there's a disproportionate amount of interference for the copper wires that are closer to that power source and less for those that are further away. By twisting the wire, all of that balances out, and so the impact of the electromagnetic interference is reduced. The number of twists per inch cancel out the differences in potential created by the field. That's the correct answer. The other answer choice that most students selected, the number of twists per inch combined the differences in potential created by the field. And if they combined the differences, that means the difference in electromagnetic interference would actually increase instead of decrease. It's the cancellation of those interferences that makes twisted pair, unshielded twisted pair and shielded twisted pair, categories 5 and higher Ethernet cable. It's one reason why they work so well. It's the cancellation. It's not, you're not adding them together, you're canceling out. Okay. The TIA standard used for wiring data networks is TIA 568B. For voice, not data, it's 568A. Voice is A, data is B. That's why this statement is false. Hub versus switch. A network switch is more advanced than a network hub. Select the choice below that summarizes the most important difference. A hub sends data for all MAC addresses to all physical ports. So it's basically just a multi-port repeater. That's what a hub is. A switch doesn't do that. A switch takes a frame based on a MAC address and forwards that to only the port that is associated with that MAC address. So it isolates and dedicates the bandwidth for each port as opposed to sharing the bandwidth across all ports. There's less contention and there's better security on a switch. A switch sends data for all MAC addresses to all physical ports. No, that's what a hub does. A hub sends data for a given MAC address to only one physical port? No, that's what a switch does. A switch broadcasts all frames to devices on the broadcast domain except the origin to prevent loops. No, that's just a bogus statement. It doesn't broadcast all frames to devices on the broadcast domain. It selectively broadcasts frames to ports associated with that specific MAC address. Okay. This concludes our item analysis for retake assessments for modules 1 and 2.